All right. So, guys, I hope that everybody can now uh, is unable to mute themselves and speak up. Okay. So let's start our today's discussion. So thank you first of all, guys, for bearing with me and to come on an call to come on special extra class for this, guys. By the way, this is the last lecture of our course. So so please confirm everybody's here able to hear me well. You can hear me and well clear and loud.
Yes, sir, loud
Yes,
and
sir.
Awesome. So first of all, I appreciate and thank you so much for your courage to join on the Sunday evening class. I know this is already pretty late. 8 o'clock is like already night here, and uh, but uh, but yeah, this is the last lecture, guys, that we have entered into, and I think this is the last time that we are going to sit in this kind of setup. I'm definitely going to miss all of your company. It was a pleasure connecting with all of you, but we will stay in touch. Okay. So let's get our discussion started, guys. Today we are going to discuss about how the cloud basically facilitates various aspects related to DevOps, scaling options, or various other patterns which are actually there when it comes to especially implementation of the microservices based architecture. Okay, so good amount of things would be covered in the today's session. We are going to see the details about how and when it came into the picture. What is the CI/CD? What are the options of the scaling? What are the necessities of the API gateway? How does it impact the microservice architecture? Whatever is being discussed in the today's class, guys, is not going to be alien to you because I believe you guys must be using these aspects in your every day-to-day lives. So I'm not going to intrigue you with a lot of details, but as a part of this discussion, I would lay out the details about the DevOps and various other best practices that should guys should follow in your industry setups. Okay, so the first and the foremost thing, my dear students, why DevOps? Okay, so let's discuss about why DevOps at all. I mean, you all know the answer to this particular question. But to be fair to all of the students in this class who might watch this recording later upon a time and who may not be in the DevOps practices yet, let's cover this. So generally what used to happen is, guys, if you remember in the early 90s or mid 90s, the software engineering had its own set of steps. Okay. It was more of a procedural in the nature. It mentioned clearly that in the step number one you need to do this, step number two you need to do that, and so on. Likewise, they defined the various stages, especially now the very first one, which was requirement selection. First of all, we used to meet the customer and then gather all the requirements. So probably it was one way arrow for most of the times. Now, as customers used to tell what we are going to the requirements of the software that has to be built. Okay, but and from the requirements they went into the design phase. There were two types of the designs, that is high level design and the low level design. So after the design phase, they got into the development, testing, and finally it used to go to the deployment. Now, mostly as you can see, it used to be one way arrow towards the right. So first we get the requirements, then we used to come up with the design. Now then we used to, once we get the design, then we used to develop, and then it used to undergo the testing, and finally it used to undergo the deployment. So this was mostly one-way traffic as such. Now if customers comes back with some change, that change cannot be brought up until and unless the whole cycle is completed. And for the new change, new cycle has to be started. Yes, at that point in the time, that was the only change which was defined. Most of the companies would go through the same process because everyone was following the same process. Now, in those days, the ISO for the big companies was a very big thing. I have read and seen the companies like Motorola, Lucent, Nokia exhibiting in their prescriptions, that they were following the ISO standard and so format. It was a showcase piece as such, but its meaning was that the companies having ISO certifications followed the standard practices and procedures in their processes. Of course, many such things happened in other small companies as such as well, but not to the extent of the practices and standards which were happening in the ISO certified companies. From the experience of various engineers who worked in the services domain, I had got the opportunity basically to hear from their experiences that what they had gone through the process of the requirement collection, high level design, low level design, and then going to the development and deployment. But since the things were a little flexible with them, not everything was required to be undergone through the documentation very often. Okay, there was some amount of agility at that point in time. Also, they didn't knew, but they just felt that hey, they were accommodating some amount of changes from the customer side. Okay, nothing was freezed as such. They used to accommodate those changes and let's say that hey, it's fine with them because they had to satisfy the customer and to make sure that their business runs and bring along some other customers as well. And the customers also did not had the whole story in their mind clearly. Through a lot of discussions, the story evolves. So after that, they saw that these processes were not working because customers started demanding the new features at a quick frequency. Small changes had to be done very, very quickly. And because of all of those needs, things became bidirectional in the nature, as you can see over here in this picture, where they brought in agile processes. Agile basically means it can change fastly and move around very quickly in both the directions. Okay. So in this age, continuous interaction happens with the customers. Requirements are collected and it goes through the process of designing, development, and testing. So it started happening in that way. But along the same path, there was also a huge gap between the developers, testers, and operations team. Operations team used to closely work with the deployment part of it, that is, moving the things to the production stage. But here we had these developers who used to develop in the various environments and they used to get the job done. And this particular gap, especially after the agile came into the picture, it started widening because things were more frequent now. Like development was happening more rapidly now. Okay? Just give me one moment, I'll be back. All right. So sorry, guys. I had to attend to the baby. So sorry for that. Yeah. So so now, guys, what we were discussing here. So we used to get into the dialogue between the dev and the ops guys usually, where dev would say that, hey, put the current release to live now to the production because it works on my machine. As due to the client pressure, we need this yesterday. In case the production sanity fails, the developer guy may also say that, hey, you are using the wrong version. Ops people would need to get answers for many things, like what are the dependencies. At times, he would say that, hey, no machines are available in order to deploy. And he may also ask which DB to be used, what kind of high availability needs to be provided, how does scalability would work, right? So for some of the answers, for some of these questions, actually, the answer would not come from the developer. But for some of them, and some of these questions would not even have undergone through the thoughts from them. So there is a difference in the environment in which these two people would work. Okay, there is always this kind of clash going on. In fact, some of you would have experienced this in your journey of your career also, right? At some point of time or another. So engineers of the right recent age might not have experienced this, but people who are older than 5 or 8 years in the industry, they would surely have experienced what I'm trying to say. So a lot of arguments would be there on this front. They would have to come up with some such solution and somehow would have to marry these two guys, right? Basically, they had to work together with each other in a amicable way, in a very, very positive way to find answer to these questions and to solve this puzzle, right? All right. So there was a need for the faster deployment cycles. Why faster deployment cycles? If you look into that particular chart, what is this? Which is the output of the Phoenix project at Amazon. The development frequencies there are around 23,000 deployments per day. And the lead time which they take to deploy the changes are in minutes. Okay. So reliability which is required is pretty high. Customer feedback is of course very important. For Google, they do around like more than 5.5 thousand deployments per day. And same the Netflix does more than 500 deployments per day. For typical enterprises, the deployment frequency is once in every 9 months. So you look into the top two, three or four rows to know the gaps which exists in developer to the operation side. It definitely does not help. You need to have a converged environment between these two people, that is devs and ops guys, so that they can work in an environment where there are no more clashes and no more arguments. Things are smoother in the nature, right? So that's what about like the need. Now, talking about what exactly is the DevOps. So it is nothing but it is the dev and operations. It is termed basically it's termed as the process which aligns development and the operations. As please note that the keywords over here is better and improved communication. Both of them need to align in a very good way. You need to have better dialogues and communication. No more arguments like, if one talks, the other one can hear, and it should be two-way communication. So Microsoft defines the DevOps as the union of the people, process, and the products. These three pieces enable the continuous delivery of the value to the customers. You're not delivering the product, you're not delivering some piece of the software. You're adding the value to the customer through which customer business is likely to grow. That's the output which is actually expected. So for this, the whole DevOps methodology involves the integration part, the delivery part, as well as the deployment part, where the steps like building code, testing code, and merging the code forms the continuous integration. Moving to the delivery phase, where the code changes are automatically released to the production repositories. And from there, it is deployed using the automatic deployment tools to the production. And finally, it is available to the end users. All right. So what exactly is the DevOps, guys? The DevOps is nothing but it is a set of practices intended to reduce the time between committing a change to the system and the change being placed into the normal production. During this process, it has to make sure that it maintains the high quality. So that is the definition of DevOps. And its implications are you would have to know the best practices as well as tools. Now, just practices does not help. You need to even take help of various tools which are actually there. And do not restrict the scope of the DevOps to the testing and development. You should try and bring in the culture across all the platforms so that people start working in that particular mind frame. right? So these are the various software processes which evolved over the period of the time, and agility is definitely one of it. See the picture? As you can see, there is no separation as such, but only color coding is there, where development involves planning, coding, and building, and along with the testing. From the testing phase, it goes to the release stage, and then it is deployed to the production. We then operate and monitor it. Finally, it comes back into the planning stage. And if you keenly look into this particular figure, this is the mark of infinity, meaning to say it does not stop over here or there anytime. It continues to keep happening without breaking this chain of plan, code, build, test, and release, along with deploy, operate, and monitor. And again, it falls back and restarts from the plan phase. All right. So that's what, guys, it indicates the DevOps. So do you understand all what is the DevOps? Is there any question anyone have on the DevOps before I proceed further? If there is any question, please ask.
No, sir.
All right. All right. So let's move further, guys. So the generic way of how did the things used to happen was, of course, the first phase was the development. The next phase was operations. Now there were various teams. That is like we have the development team, testing team, operations team. Of course, this was being led by the project manager who used to lead the planning phase of development. Then used to happen development, continuous deployment, and continuous release, along with continuous monitoring, feedback, and optimization. So the whole thing put together forms the various phases of development and operations, which in short is also called as DevOps. The methodology with which the time this is being implemented is called as agile methodology as such. And the one who participates in these various phases would be called as DevOps engineers. So now let's look into the various phases of the continuous integration, continuous delivery, as well as continuous deployment. What exactly do they really mean, right? So, so now let's talk about the continuous integration. As the name itself suggests, as the code does gets frequently changed, it could be either you are fixing a bug, or it could be a new feature being implemented, or it could be some feature which client feels that it is not helping. That is also a change. Removing something from the code is also a uh, change. Now, as soon as the bugs are being fixed, they need to be moved to the production as soon as possible, because you never know how much of the harm this particular bug could lead you to. So you need to make sure that the code changes are merged to the main branch and they are moved to the production at the earliest, especially the security bug fixes. Okay. How soon can you merge the code fixes to mainline branch? How fast you can build the whole thing, test the process and make it production ready? That is a part of the continuous integration. For all the things to seamlessly happen, you obviously require the help of automation tools. What do we call as a successful AI? CI/CD? Answer is you should be able to build, test, merge, and send it to the shared repo in a quick cycle. The goals are faster identification and fix of the bugs, improved software quality, and reduced time to release to the production. So the moment you can merge the code to the mainline branch is basically called as continuous integration. Let's move forward, guys. So the next part is the CD, which stands for delivery and deployment. Delivery means you are looking into the release of that software which is either newly developed or bug fixes which were added to the production environment. So basically, delivery means you're looking into the release of the software which is either newly developed or bug fixes which just happened. Here, this particular delivery, it makes sure that the automated flow, which is built using build code testing in various stages through which it has to go through, gets its work done by the repositories, right? Like GitHub is there, container registry, where container images are being stored. So here the whole flow is actually automated using various tools to make sure that there is a continuous delivery platform. The goal over here is to make sure that the code base should always be ready for the deployment to production environment. You need not to have your code base always ready as such, and it cannot be in between stage, right? Next, continuous deployment. Continuous deployment means that our code is getting deployed to the production environment. Whatever changes that has happened to the code, whatever the fixes which were done, whatever the new features which were added to the repository, they are all now put on the production environment. Basically, to run it, to make it available to the end users, the customers. And this one, it could be also consist of the big releases that we do to the customers. How all of this is being made possible? With the help of automation testing. So it's because of all of those things, unlike the previous versions of the software engineering. So see, every software release were being built for the enterprises. Enterprises were using this software for their various needs. The general public which was there, they were not the software end users or customers for that matter in the earlier era. All those things opened up, especially after the advent of the smartphones and the easy access to high speed internet in the smartphones. With smartphones coming into the reach of the common man, various applications were being made available to the public. End users were like kind of having accessibility to a lot of softwares, and that's when it comes about the discussion about scale, growth, etc. So growth and the scale is so huge these days that the things have to be automated. I mean, things were forced to be changed from the traditional way to the automated way of continuous delivery and deployments as such. Okay. All right. So these are the various stages of the releases, guys. I will talk about now. All right. So you have open source basically code which is checked in. Basically, it could be all the .java files or .cs files if you're in .net or Java respectively, which goes through the peer review. Now the team members review this particular code and say that hey, it is fit to go to the production. The team members review this particular code and they verify, and the tester developer verify that it doesn't break the code, it doesn't break the environment in which this particular software is actually working. Okay, then you go to the build phase where that code is completed, then code is compiled and code is unit tested. Style checkers are executed also, like Sonar is there, etc. And if it is container based, then the container images are created and they're packaged to make sure that they're deployable. Okay, then you have to uh, execute the test phase where the integration testing between the different modules takes place, along with other testing like load, UI, security, etc. All of these testings are also done. Finally, we move to the production where this particular code is being committed for production as such, and it is made available to the end users. Okay. And this particular code is often monitored continuously to see what exactly is happening with the code. So in the case there are any errors or issues, immediately they are all quickly captured and immediately you come back to the planning phase where you discuss and see how can you fix this particular bug. Okay. So fine now guys, now you move into the CI/CD pipeline. Eyes closed. CI/CD pipeline is nothing but it is a series of steps which you follow in order to deliver the new version of the software. Okay. You can see that you have source control like GitHub, Sven or something similar to that. Code gets committed to the source control. From there, it goes to the staging phase, and then it goes to the production phase. And what constitutes the continuous integration? What constitutes a continuous delivery? And deployment is depicted in this particular picture, as you can see over your screen. Of course, the same thing can be demonstrated in the other way as well. You can see here that a new branch has been created and the work happens in this particular branch. This branch is next committed to the main branch. Then automated build and test steps are being run. That is, whatever the code is there, that is being put into the build and test phase. It's a continuous activity as such, my dear students. This is like it could revolve in this particular phase multiple number of times before it is reviewed and approved. Finally, it is merged into the production code and it is deployed. Continuous integration, delivery, and continuous deployment is fine. But how will it affect the various architectures with which these applications are being built? Of course, the two architectures that we often compare these days are between monolithic versus microservices. And of course, in between, we did have the modular architectures as well, to which we also called as the layered architecture. This was not a monolith as such, but still the comparison purpose, we still go back to the monolith versus microservices architecture discussion. Okay, so as you can clearly note down in this particular figure, my dear people, in monolith, say if multiple teams are working on the multiple pieces of the code, and if one particular team member pushes the erroneous code into the repository, which can perhaps break the whole thing, then it would end up breaking the release candidate as well as affecting the production release, isn't it? But microservices architecture is not built in this manner. It's mostly built in one is to one manner. Every team have got a code base for their respective feature and changes into it shall be released to the production through although it's a separate pipeline, that's a separate entity. Of course, it works with other entities as well, but that's a standalone entity. But it works, communicates with other services as well. So if some particular code breaks, some particular feature, only that particular service would get affected and it is not going to affect the other services as such. During the interaction, you may come across a way that there is an error which has occurred. Okay, most of the times we do get some such situations. These days, though, it's very much roller coaster in many startups. I mean, it's not annoying, but let's assume that we get errors and something went wrong. Please try again after some time. Okay. So basically, I mean, it looks nobody really knows what went wrong because it's all microservices architecture and it's a distributed tracing that we need to have. There are so many pieces which are actually involved. You get to see such kind of messages from Amazon Prime, Netflix, and that matter. I mean, these errors are very infrequent, but at many places you get such ambiguous messages, or probably I can say very clear messages that something went wrong. Please try again after some time. The assumption is that probably a container failed. A container which was hosting a microservices failed, and basically it needs to be restarted. And of course, because of that issue, it came like the services are temporarily down and things will come up again. Of course, there are orchestration tools with which using which it will get restarted. So what they are attempting to say is that there's something went wrong, and even if I give you the details, you will not be able to understand it. Please try again after some time, and things will work for you. And because in that small amount of the time that which they are asking for, there is a very good chance that this particular container would get restored and it shall be functional again soon. So it has not brought down the whole code, but it is not saying that the whole application has gone down. It is only saying that the particular piece did not work well. Please try again after some time. That's what they are trying to say. So that's the impact that we are seeing using the microservices architecture as such. Okay. So microservices, you can say that one service, one pipeline, and you can plan for a very high amount of releases as such. Okay. Whatever I just explained is being mentioned over here, guys. Each team can build and deploy the service that it owns independently without affecting or disrupting the other teams. Before a new version of a service is deployed to the production, it gets deployed to dev, test, QA environments for validation purpose. Quality gates are enforced at each stage. A new version of the service can be deployed side by side. It's reiterating on whatever we just discussed in the previous slide. Okay. So guys, there are thousands and hundreds of the tools which will participate or which will help you in the DevOps journey in the development size as well as the operation side. You can see here that there are some infrastructure building tools. There are some tools which helps in the testing. Then there are some tools which helps in the development and deployment. All those things are actually there, but the question is, do we need to really know all of these tools? So answer is not necessarily, guys, because there are some set of popular tools, and in case you're aware of them, it becomes very easy to navigate through the entire process of DevOps. Although it's very easy to pick up the new tools as well and build your own expertise on the same as well. Some of the popular tools which you might be aware and using would be like Jenkins, GitLabs, DevOps piece of AWS where you have multiple services for each purpose. DevOps piece of Azure is also there. See, Azure DevOps is a complete piece. You come in, you go out with a full pipeline as such. But in case of AWS, there are individual services which are available using which you can complete your pipeline, like code build, deploy, etc. Now, there is also a new tool out there in the market called a Spin Maker, which is like a continuous deployment platform for multi-cloud environment. These days, people are going for multi-cloud as well because one, of course, vendor lock-in is a tricky thing. Second, there could be some particular services which are offered better in one particular cloud than the cloud with which you are associated with. Okay, thus enterprises are slowly moving towards a platform where multiple clouds are involved as such. Then you also have a tool like Circle CI, uh, Travis CI, Go CD, etc. These are some of the popular new age tools which are available in the market, which you can try. And the tools which appear in the CI/CD workflow are the one is information with infrastructure automation. These offer the tools which look into the infrastructure part of it. It could be the VM creation, it could be container creation, or it could be setting up of the multiple machines with a specific set of software requirements as such. Tools like Ansible, Puppet, Chef, CloudFormation, these are all infra building tools. These tools help to create infrastructure for us where we can run our businesses and services. Likewise, you also have your AWS SAM. SAM toolkit basically stands for serverless application model, sorry. SAM is an open source framework, guys, which is used to build serverless models or applications. Okay, then you need to have a runtime where your application needs to be deployed. Now, because we are looking into the microservices based architecture, Docker fits the bill very well. When I say Docker, uh, I'm referring to the container as such. Now, next, there might be thousands of the containers. Now, question is, how do you really manage all of those containers? The Docker came up with Swarm, but for some reason, did not took off very well, and thereby Google came up with a concept called as Kubernetes. That is available for anybody to work with. That is, it's open source now. These days, Kubernetes is becoming a de facto standard with the tool in order to orchestrate the containers. When I say orchestration of the containers, I hope now you understand it, as there was one complete session on the Kubernetes where we discussed how the orchestration now takes place. What are the various advantages of the Kubernetes, etc. Okay. So now, guys, what are the benefits of the DevOps? So you see a good amount of the reduction in the time consumed in the fixing and maintaining the applications. Also, you see a considerable improvement in the application quality and maintenance, and thus increase in the revenue because things got automated and speed increased thereby. Yeah. Also, there is a considerable increase in the infrastructure improvements. When I say infra improvements, basically when it comes to auto scaling, we don't have to go through the long period of getting the approvals to implement the changes. Okay. Then there is a major reduction in the application release time as well. There is a this is a huge reduction. Now, this slide demonstrates the evolution of the process, architecture, and application development and deployment as such. Okay. 1980s to early 1990s. It was mostly the waterfall model which was being followed in the software engineering. One after the another could not basically basically what I'm trying to say is that this model could not go really well um, you, because if you want to go back, then it would have to be new cycle as such. And the architecture was mostly monolithic in the nature, having multiple functions being implemented, running in mostly single threads. Okay, that was the architecture with which the applications worked. The deployment and packaging was mostly in the physical servers. So we had the physical servers which had all the stuff. I mean, starting from the operating system to all the dependencies, libraries, the middleware, and whatever was required was installed. The application was deployed. And these physical servers, they used to be the part of the data centers. Moving on to the 2000s, the things became little agile in the nature, and we started seeing multi-layered architecture with respect to application development. And most of these were getting deployed onto the virtual servers and not the physical servers. We already looked into the advantages of the virtual servers or the physical servers in our previous classes. And mostly the application infrastructure was hosted in the nature where the application was hosted on the servers or virtual machines, so the instances as we call them. So nowadays, what we have is basically called as DevOps, that is continuous development happens along with operations. And application architecture is moving from monolith to microservices based architecture. But even to this day, there are a very good amount of applications which are still monolithic based. When I say monolith, I mean they follow layered architecture and servers where deployment takes place on containers. Now, because we know for a fact that how we quickly we can deploy a container as compared to the virtual machine. And that infrastructure mostly is on the cloud because you tend to get a lot of services which are inbuilt into the cloud. All of these are managed services. Okay. So, guys, that's what I have to talk about the CI and CD stuff. So, now let's move our attention to APIs and gateways. But before I move to that, do you have any questions or any doubts in this entire discussion that I did? Please ask. All right, so no doubts, guys. So let's move on our discussion. So we will proceed now to APIs and gateways. All of you can understand it, right? You give me some yes, thumbs up, yes, no in the chat window. बता दिया तो पता है क्या होगा? तेरे को भी जेल होगी, मेरे को भी जेल होगी, पापा मेरे को भी जेल होगी। चाहता है क्या कि हमें जेल होए? हम्म? स्कूल में किसी भी बच्चे के लगा दिया ना तो जेल हो जाती है। सो जा बेटा, यहीं सो जा, तो मत जा प्लीज वहां पे। बहुत लड़ाई हो जाएगी, बढ़ जाएगी लड़ाई। सो जाओ। आइस क्लोज कर ले और सो जा, राजा मान जा, मत तू हमारे बीच में कलेश करवा। मरने की सिचुएशन हो रही है बिल्कुल। All right, so guys, now let's talk about APIs. What is an API? API is an agreement which stands for Application Programming Interface. It is a promise or an agreement between the client and the server. Client makes a request through an API call. Earlier we had various other ways of the getting the function done. Now we had RPCs, which is also called as remote procedural calls or RMI from the Microsoft's end. Then Java had its own way of doing the stuff. I think it has JMI or something like that. Okay, so all of them had their own way of interfacing with the services or getting the things done, but slowly they moved into a space where the API calls were done. Basically, you create the programming interface where client can interact with the server. So these dependents, basically these depends upon the IPC, that is interprocess communication between the different servers for that matter. The definition for this API depends upon what kind of IPC mechanism you actually use. We shall see that in the later slides. So these APIs are likely to change. Why? Because features go out of use or some features might change over the period of the time, right? So with respect to these changes, APIs also got to change little bit. And when it comes to the microservices architecture, we always adopt the API first approach. API first approach in the sense that talking between the various services only through the APIs. And there are so many public APIs which are public facing APIs which are available, using which we can come up with our own applications. Okay, for example, Google Map APIs is being used in multiple other applications, like for example, in a lot of different applications, like earlier Ola used to do this, then various new age internet companies are using it, right? See, if at all we are thinking and planning to create a native mobile client, say for shopping experience, then it is likely to have the various pages. For example, it is going to display the number of items in the cart, order history, product information. Likewise, there might be some other parts and pieces of that particular activity. So, how does this mobile client access various services? These are all various microservices as such being deployed in the various containers. Now, the question is, how do they interact with each other? Understanding one thing, all these different and devices, they have different requirements. It could be of the same data, but this data has to be placed in the different forms in order to cater to the various types of devices. Okay, so if something needs to be brought into the Android or iOS application, you may have to perform some additional processing before it can be shown in those devices. For example, because of the size of the data, you might have to compress the data before it can be transmitted to the devices, isn't it? So what I'm trying to say here is that all the different devices, they have different needs. And another thing that I wanted to point out is that with increased number of microservices, obviously the number of endpoints from these microservices is also increasing. And the management itself becomes a pain point from the client's perspective. For the case of the browser, it's easy to roll out the change as you only have to deploy the change in the pipeline. But especially when you're talking about the native applications which are developed for Android or iOS, you of course need to make changes in that application and roll it out also. Next, there exists a problem of load balancing. Okay, and there are thousands of the clients out there which are directly connected to these backend services, and these clients are trying to get some business done through the help of these services. So load balancer could be one of the problems. Now next, is it secure enough to allow the devices to directly talk to the backend services? Might not really be the case as such. And added to all of this, if at all you're building an application with some UI, imagine that you're populating one particular screen which is using a very large number of microservices. So also believe that this particular screen is getting painted, populated because of the data being supplied from a large number of services. Example, probably you might be seeing the order information along with that. You're also seeing that information of the new orders which are being placed along with that. You're also seeing what products do you have in your cart already. Probably your UI screen is getting populated by so many microservices as such. If that is the case, it can quickly increase the latency for your UI screen, isn't it? Because of the multiple microservices which are populating the UI screen, they have to make separate requests to all of these services in order to get the variety of the data needed to paint the UI screen. Although these calls may happen in the parallel, still we would have to wait for the RDT, and because of that it can lead to increased latency and ultimately applications performance is going to suffer. Yeah. So now what is that I can do in this case? The idea is to bring in a facade. This facade is basically called as a boundary layer. This boundary layer is basically going to act as a front layer for all the interactions which happen in the internal services. So this facade layer would abstract out complexities of individual microservices and their APIs as such. So through this facade, you can get access to the data and functionality in an appropriate manner. This is how it is being built. This is also known as API gateway pattern. Now your applications are on different devices and you have to target only one particular endpoint with the necessary parameter which shall be the API gateway. So that shall be the entry point. Now consider the previous example. Look at the way it is actually architected. Okay, so all the requests which shall first come at the API gateway will then make sure that which particular service needs to be used in order to provide the requested data to the customers. The various key features of the API gateway are being listed over here. You can see the request routing. You can see in the right hand side of the picture that depending upon the various factors like access path, signature, requests, basically different requests would get routed to the different microservices. And it can also help in the protocol translation. For example, there could be some known standard protocol which are being implemented in communication, something like AMQP, things like that. We need to make sure that there is a translation happening from AMQP to probably HTTPS or something else in order for the communication to be done. Next, you have API gateway, which also helps in API composition, meaning to say, if at all say I need to gather the data from the multiple microservices, then using the API gateway, I can very well gather the data from the lot of microservices and I can return it to the client. Okay. And it also helps in implementing the edge functions. What are the edge functions, by the way? This is in reference to authenticating the users or authorizing the users with respect to access controls. Next is we have limiting the rate at which the clients can access our endpoints. Caching can also be the part of it. Logs can be collected, metrics can be collected at this API gateway layer. Okay, as you can see here that the API gateway is getting requests and it can in turn make either a REST API call, a GraphQL call or gRPC type of call. In nutshell, in this picture, you can see that there are multiple protocols being used here to get the things done. Okay. All right. So there is API gateway architecture. So let's take a 2-minute break and I'll be back with a glass of water before we go into the discussion about the API gateway architecture. Okay. Till then, if you have any questions, please type in the chat window, and I will happily able to answer it after I come back with a glass of the water. Okay. Thank you. All right. Is everybody with me, guys? You can hear me out and you can understand what I'm speaking. So far, whatever I have told, does it make sense? Can I get some yes, no's in the chat window? Okay. So let's move forward. The first is so there are various clients uh, in this architecture of the API gateway, as you can see, my dear students. Next, in the API layer, there are various services which will handle the request coming from various clients, and all the clients are basically the requests are being sent to the common layer. The benefits of having the API gateway layer is that it will abstract the functionalities of our original backend services. It will simplify. It also basically simplifies the client code because the client does not have to talk to too many endpoints. The drawback could be it could be another layer or hop which is added to your whole application architecture. an additional hop, or basically everything has to pass through this layer itself, which could lead to the slower performance if this particular layer becomes the bottleneck. To avoid this layer from becoming a bottleneck, we can have the cluster of API gateways. So in order to implement the API gateway, guys, there are cloud services like AWS API gateway. We also have the Kong, which are off-the-shelf options for implementing the API gateway. If at all you want to develop your own API gateway, you can make use of the API gateway frameworks. Like Zool is there from the Netflix, right? In order to develop your own API gateway, you can basically use that. So this is how, guys, you would find like you can also start to execute your API gateway implementation. You would have your request and response coming in here at the API gateway, and API gateway is basically redirecting the request either to the REST API or to the Postgres REST API to the Lambda, and that's how basically your API gateway would function. Now moving to the final part of our today's discussions, which shall be the deployment, scaling, and availability using the manager custom containers. What is scalability, guys? Scalability is a term which is being used in the software systems to define NFR. What is NFR? Known functional requirements. You might have seen in various system design interviews or discussions coming up, right? That scalability is a known function requirement which can handle the growth, meaning but without defining the scalability. We have used the scalability concept in our previous classes as well. Here we are talking about the capability to handle the growth by changing some dimensions of its operations. What is this dimension of operation? Number one is depending upon the simultaneous users or requests which are coming on our application, your operational entity should be able to process them by not elongating the queue. And next one is amount of the data that a system can effectively process and manage. Basically, here we are talking about the DBMS. DBMS in the sense that how effectively it allows us to query the database in order to effectively query and manage it. Right? So there are two ways of looking at it, my dear students. One is a scale up and another one is a scale down. Scale up refers to increasing the capacity of the individual resources within a single server or instance, where scale down is a completely opposite of it, where you reduce the size of the individual server or instances. This kind of behavior is also termed as vertical scaling. In usual practice, you usually start the virtual machine with higher CPU or higher RAM. That is how the virtual machine is vertically scaled. Of course, the scaling can be used in the two other formats as well, like scale in and scale out as well. Scale out means basically adding more instances of the nodes to the system to distribute the workload across multiple machines. Whereas scale in means removing the instances from the system. This kind of behavior is also termed as horizontal scaling. Now, as we just mentioned, here you can see the same thing in the slide as well. Scaling can happen in vertical as well as horizontal ways. Vertical means you change the configuration of that instance or machine. Okay, so for example, you are currently using T2.micro type of instances, and you plan to switch to any other higher type of instance, say for example M5.large. Then the situation is basically called as scaling up or vertical scaling. On the other hand, horizontal means here you are increasing the overall capacity by adding more number of machines rather than modifying the capacity of a single VM. Hence, we increase the capacity by adding more machines side by side. This is also called as horizontal scaling. So here is the example that we just spoke about, guys. On the right hand side of the slide on your screens, you can see that auto scaling can add more number of instances automatically. based upon the requirement. At the same time, it can also bring some virtual machines counts down as well. Next, there are various deployment patterns for applications on the cloud. The one is a language specific packaging format pattern. Second one is a service as a virtual service pattern. And third one is a service as a container pattern. And let's look into each one of them. The first one is the language specific packaging format pattern. It confines to the specific language. Say, for example, your application is Java based. Finally, your executable shall be either a jar or a web archive. That shall be output from the deployment pipeline. In the infrastructure itself, you have multiple machines which will have facilities for you to run the Java classes files. So what we need to have is JVM. Okay, here throughout you have an application which is Java based. All the services are being deployed in the Java language. But if there are some other services which are being developed in a different programming language, then we shall have to move from the language specific packaging pattern to the service as a virtual machine pattern, right? Now, in the case of a service as a virtual machine pattern, each of the particular services being packaged in a virtual machine image, meaning to say, first you start a virtual machine, you put in the required service code in that machine along with the configuration files and other details, then you create an AMI, that is virtual machine image as such. Using this AMI, virtual machine image, you shall be able to deploy new machines. For example, Netflix makes use of EC2 AMIs, that you have EC2 images. Netflix makes use of these images to deploy its services. Okay. So here, as you can see, you have your service code. Using the VM image builder, you create the AMI, that is Amazon Machine Interface. Now this AMI is being used to deploy multiple EC2 instances which shall host the service. Then you also have the ELB which shall take care of the balancing or dividing the multiple requests which are coming onto the ELB amongst various EC2 instances. Sideways, you also have the auto scaling group, which basically helps in adding or removing the instances depending upon the load situation. So this is the pattern which makes use of the virtual machines in order to deploy the various services, right? Likewise, we also do have the container pattern as well, my dear students. The main difference between these two is that it doesn't make use of the virtual machine, but rather it makes use of the containers. Here also we make use of the containers, but containers are used to host the containers. Here I could basically have different containers running in the same VM. Using the Amazon ECS, we can have same service, some service instance, which is actually running, which could be Python based. There could be another container in which another service instance would be running using Docker, which runs on the Docker runtime as such. So all these possibilities are there also now. So now if you see how a service is being deployed using Docker, first we have to build an image for the service. I mean, first I shall have to write the code, package it, create it, build an image. Then this Docker image shall be pushed to the repository, that is container registry, which is being maintained by that organization. Then whenever there is a new request which actually comes in, this particular image is being pulled and the new containers are being created, which shall host the services. Okay. So we have service to host models also. There are three common models in which we can deploy these services. One is a single service to host, second is multiple services to host, and last one is multiple scheduled services per host or container scheduling. So the single service to host model looks like this, guys, where each virtual machine is configured with only one service. Basically, it is capable of hosting a single service. So one virtual machine means one service. Yes, it has its own benefits. For example, there is a service instance isolation. When I have the service instance isolation, it becomes easy for me to manage them as well as monitor them. I can clearly know as to what particular service is being failed, and I shall also know through the mapping as in on which particular host this service is being hosted. This helps by not conflicting on any service requirements as such. But a major drawback here is that it makes use of a lot of hardware resources. It's all hosted using the virtual machines. Therefore, with respect to the resource utilization, it is less efficient. So moving into the next one, where I can have multiple services which shall run either a physical host or virtual machine. So here it helps me to make my environment efficient by having multiple services. But the platform is, I shall not be able to monitor them better. Monitoring becomes a challenge. Isolating the instances becomes a challenge. Okay. And finally, we have multiple scheduled services per host. Okay, we make use of the container scheduler. A container scheduler is something like a container orchestrator, which shall help us to create this atomic containerization application using a shared pool of resources. Finally, we have, you can see in this picture, it shows you the various ways with which you can run the microservices. The source code first gets executed in a VM, and if we are using containers, we can have containers being executed in the VMs. That is ECS plus EC2 together. ECS is a container service on EC2 services. In case of containers, you would also bring in the orchestrator service, which shall manage the containers in the VMs. And finally, these gets deployed as serverless containers, where you don't have to really manage the infra as such. This could basically be the serverless execution, guys. Lambda is also a serverless function, or it is a unit in the AWS. Now moving on to the various ways to run the microservices, as you can see. Guys, one is a single machine, multiple processes. Here we can get a server virtual machine and run multiple microservices as various processes inside that particular server or VM. It's a process isolation here, where each microservice shall run as a process. The next one you have is multiple machines and multiple processes. That definitely is the obvious next step from the previous one, where you had multiple servers and you distribute your services across these multiple servers in order to distribute the load which is actually coming in. Okay. Obviously, this approach would provide me with greater availability and scalability as well. Yeah, but we also have the containers where packaging the microservices inside a container would basically make it the lightweight entity, which are easy to deploy and run. So these are built-in architecture, which is not at all fail-safe, which is basically, which means containers are bound to fail, and there shall be failures. Now, once you have containers, you would need the orchestration tool. By default, Kubernetes can act as orchestrator as well. Okay, finally, something which you can look for without even bothering about the hardware or the VM or the container, we can make use of serverless computing. Here we do not have to bother whether our service is running in a VM or a server, or is it running as a container, or you just manage and develop the code in the cloud. For that, you can make use of the Lambda functions. All right. Now let's look into the various scaling strategies for applications running on the cloud. The first one is a vertical scaling the entire cluster. Next one is the horizontal scaling the entire cluster. Then horizontal scaling of individual microservices and application. And next is elastic scaling the entire cluster. And last but not the least is elastically scaling the individual microservice and application. So guys, these are the various, what is the vertical scaling of the cluster basically, right? So here you can see so vertical scaling means, guys, where we improve the configuration of the machine, correct? Why is that we have to improve or increase the hardware configuration of the machine? Say your VM has got 32 GBs of the RAM. Then why is that you have to make it 64 GBs or 128 GBs? Say your VM has got 8 vCPUs. Then why do you intend to make it 16 vCPUs? It's because your VM server actually hosts the runnable entities called containers. I mean, you don't have the provision to launch infinite containers. That is basically limited by underneath the resources allocated to that VM server, isn't it? Therefore, total capacity of this virtual machine would define as to how many number of containers you can actually run. So vertical scaling, what it does is it helps you to launch new VMs with a higher capacity, and then you have Kubernetes cluster run over it. This is where migrations come into help. Okay, what is it you have to do? You basically have to migrate your applications from one set of VMs to another set of VMs. Okay, you don't want to have a downtime or uptime as such. So better ways to have minimum downtime or leveraging this migration. So you create three new VMs, create a whole environment over there, and schedule a period where these clusters, which is hosting your application, will get migrated from three VMs, which have less hardware configuration, to better three VMs with higher hardware configuration, right? Of course, this arrangement will be definitely much more powerful and larger VMs, right? So that's the vertical scaling. Now, similarly, you can have horizontal scaling of the cluster. This is very obvious. So there are three VMs which are hosting your cluster of microservices. Okay. Horizontal scaling, what it does is instead of three, it would launch 6 or 9 machines depending upon the configuration detailed. So here I don't have to get into the migration part. Mostly the horizontal scaling is what is usually adopted by the most of the applications. Okay. But if at all you want to make your VM or host better, you have to get into the migration process. Next is the horizontal scaling of the individual microservice. So here what is happening is I have a single microservice which is serving the requests which are coming in. Okay, but now you would want to have more of it because here there are more requests which are coming in. Since there are more number of requests which are coming in and your microservice is not capable of handling the increased load, therefore you now bring in the load balancer. Okay, the microservice which is running in this container shall be replicated to multiple numbers so that they can handle the increased inflow of the requests jointly. Now next we have the elastic scaling of the cluster. This is where we bring in the automation. Here it means dynamically and automatically our cluster can scale depending upon the demand. If there is more demand, we can scale up, and if there is less demand, I can scale it down. So I have a Kubernetes kind of setup. And obviously, it can be scaled up and down dynamically. So whenever there is a demand, K8s can launch more resources, launch more containers, and host multiple containers. If the demand is low, it can do the opposite of it as well. Okay. So it saves the cost and it just runs using the single piece of code, which is simple configuration. On your screens, you can see here that the name of the node pool is being defined over here. What's the VM size, what's the auto scaling policy, etc. In case you are not enabling the auto scaling, then it shall be off. In case you are enabling the auto scaling, then what's the minimum count, what's the maximum count of the virtual machines, right? In the configuration example shown here at the screen example, minimum count of 3 says that minimum of 3 VMs shall be running at any given point in time. But depending upon the load, this count of VMs can go up to max of 20. That is the code which is written in that Terraform. What is Terraform? Terraform is nothing but it is a tool which helps in writing the infrastructure as a code. So using the code, you build the infrastructure. In our course, we're not going too deep into the Terraform, but this is something that I just wanted to scratch the surface with you. Guys, then I have the fifth one, which is elastic scaling of the individual microservices, right? So here you want to increase the number of replicas of the microservices in a dynamic way. This is also done using the Terraform. The Terraform script is written using the YAML scripting language. So you specify your app specifications like your minimum 3 VMs, maximum 20 VMs, like that. What kind of target is it? Is it is deployment? We also specify the service name as well. And with this service name, it would know what service is under discussion for scaling based upon the configuration which is specified over here. Okay. So you specify like this basically min replicas and the max replicas. So that's all, guys, that I wanted to cover into the scaling strategies for the cloud. So we covered three important segments: scaling strategies. We also covered like about the availability, deployments, etc. I covered about APIs, gateways, and finally I also covered about, to begin with, DevOps CI/CD. So that's all, guys, that I had today to cover for all of you. I'll take a quick pause to check if you have any questions, if you have any thoughts, anything that you wanted to ask me with regards to any matter.
Hi, sir. Am I audible?
Yes, Madhukari, I'm audible.
So here I have a doubt regarding the elastic scaling of the cluster. So basically, we are achieving that through the ASUs, like auto scaling groups, which are attached to the cluster, so that the node instances will be up between the minimum and the maximum counts. That's what you are trying to say here.
Sorry, you would have to repeat your question because your voice is not properly audible to me. Can you please come again? Your question is with regards to the elastic scaling, right?
Elastic scaling. Yes, sir. So
Can
basically, elastic scaling is that based on the traffic, the instances will be vary between the minimum and the max count, which we are defining through the module, Terraform module, isn't it, sir?
Yes, exactly.
Then how does it differentiate from the ASE auto scaling group, which we are attaching it to the cluster, and that will also do the same functionality, right? Like based on the load, it will auto scale and auto scale down the instances.
Exactly. So that's a good question. So see, first of all, in the Terraform, it's like infrastructure as a code tool. It does not automatically scale your resources on its own. Please understand this. This is a very important concept. Okay. It only applies the changes when you execute a command called as Terraform apply. So scaling the Terraform is manual or triggered, whatever, like manual or automation doesn't basically bothers. So you're changing the instance count from 2 to 4. So there would be a CI/CD pipeline which would update the Terraform variables. Then script would update the Terraform config and it would run apply. So please understand, Terraform does not react in the real time or CPU memory spikes, correct? But in the case of the cloud autoscaling is a cloud native functionality. It is fully automated. For example, well, we have AWS autoscaling groups. We have Azure VM skill sets, right? So autoscaling happens automatically without the user intervention in the cloud. So therefore, don't get confused. So let's take an example, okay? Consider that you have your CPU which is reaching 90%. So what would happen in this case? Your cloud autoscaling would automatically add more instances immediately. But in the case of the Terraform, nothing would happen unless somebody would do the code change. He would update the configuration. He would run apply button, right? So basically, Terraform scaling, elastic scaling, you would basically perform when you are setting up your infrastructure. That would not change every now and then, right? So and you would use auto scaling of the cloud provided when you have the real time load changes. You have high traffic application, you have dynamic workload, right? So that's about uh, that's about a Terraform. Is it clear? Does it make sense?
Yes, sir. Understood.
Okay. Any other question, guys?
So we are getting submission option on Takshila for the assignment. So do we have to submit again? We have submitted by mail.
No, 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 no. It is not required. Thank you very much. It is just open because I have started the marking for that. So no need to submit again. Your
Okay,
part is
sir.
done.
Sir, about the upcoming comprehensive exam, so
Mhm.
what will be the syllabus set? Like after midsem only, or do we need to prepare the whole 16 classes concepts?
Yeah, that's a good question. So, so what we are basically doing is like we are focusing majorly on like your post midsem content that we have covered, right? Majorly about like your um, uh, like for example, we covered about like a lot about uh, you know. mm infrastructure as a service coverage. We also covered about software as a service. We covered about like function as a service, right? So the things like that. Then you would also be having questions from some of the real-time tools and pipelines available on the cloud, which you can basically use. So basically, some practical questions would be there. Another type of questions you can expect is something related to like for example, some practical situations, like for example, you're acting as an architect in your company, and how would you basically design something similar to multi-tenant based application like that we talked about yesterday, right? So what would be the security issue that you may come across? So what would be the compliances that you have to take care of, something like that, right? So please learn about the compliances that we talked about in our lectures a lot. That would really help you a lot, right? So something like that. So you can also expect the questions from the like for example in the real-time industries, how they would use the multi-cloud, how would they improve the reliability, cost efficiency into the cloud, what would be the architecture, what would be storage, regions, availability zones. So focus your understanding more on the concepts rather than cramming the concept, and focus more on the practicals rather than focusing on something short term. That would be my advice for the exam. Does that give you some sense about the paper?
You mean to say that the concepts which we learn post mid, based on those concepts, the application wise, like situational learning, like that's it, right?
Yes, exactly.
So major of the questions will be from the post mid syllabus
No,
only.
yeah, you can say that it would be mix of post plus pre both. So it would be mix of both. So you can have majority would be post midsem, but yeah, there would be certain concept that would have to expire that you have to apply to your pre midsem concepts that we learned also.
Okay, sir. And I have one more question that when we saw the previous year question papers, we have that numerical questions as well. So those kind of questions will also be expected in our exam, like VM utilization. What will be the best case of the VM1, VM2, like that?
Uh, there might be, but we're not keeping it too much of the things related to the numericals this time, but you may find some practical paper questions in that sense.
Okay, sir. Thank you.
Yep. Okay, any other question? Anybody would like to ask any other question, guys? All right. So if not, guys, then I wish you good luck and I wish you all the best for your paper, which is supposedly to happen for the next lecture next Sunday. So I think today is our last lecture. So I wish you all the best. Please stay in touch. I would be more than happy to participate wherever you need my content, wherever you need my help, support, right? So I would be more than happy to assist you. And let's stay in touch on the WhatsApp group. That would be something that I look forward. Yeah. If you have some other interests, I'm happy to participate with you. Yeah, so that we can get the things rolling, we can have the discussions rolling. Yeah, so I'm very talky. I love stock markets. I love spirituality. So you can talk to me on any topic and let's stay in touch. Thank you guys. Thank you very much for all your comments. Appreciate that. And I'm looking forward to assist you further. Okay.
Thank you, sir.
Thank you, sir.
Thank you. Thank you guys. Bye bye and a good night. Bye. Thank you.